This is Professor Karafit coming to you from my secret biology bunker for Bio 1441, how to write the second lab report. Okay, so you have the data. Many of you have already done a graph for that data, and now you're getting ready to write the complete lab report. Now I'm going to give instructions specifically for my sections, so if your instructor gave you slightly different instructions, please bear that in mind. But here is the plan. Okay, introduction and title. You need a good title. You need a thorough title. You need a title that tells the reader exactly what's going on. But you don't want it to be a paragraph, and it can't be surface area lab or thermal regulation lab. No. You have to tell me what the variables were and that you use some kind of model organism. Now remember, the materials and methods kind of say that you did a model snake. I don't mind if you call it just a model ectotherm. That could be a snake, that could be a lizard. Don't get hung up on that. You're simulating an ectotherm and its behavior and how behavior affects thermoregulation. So behavior affects thermoregulation in this case. How? It alters the amount of surface area exposed to the light. And so that's what you're going to have to write about. So that's what your background is for. So what's the background then? Your introduction. You want to start your introduction broad with what is thermoregulation? Why is it important? Who does it? How does surface area and volume relate to thermoregulation? You need background. The reader reading this, pretend it's someone who has not taken Bio 2. They need to have enough background to understand what you're talking about. And citations are absolutely necessary here. So if you talk about, let's say, convection conduction, you got to cite your textbook. If you reference some kind of behavior in a snake or a lizard, cite that paper. Do not cite any web pages. These has to be your textbook or primary sources only. And so what I need you to do is really craft this. This should be the best paper you've ever written. This needs to be the best paper you've ever written. Every paper from now on should be the best paper you've ever written. But you need to proofread this. You need to take your time and craft a really good lab report. One that I could read on YouTube and you wouldn't be embarrassed. That's what you want to shoot for. I'm not going to do that, but that's what you're shooting for. Okay, so you need background. Next, now, I want to point out, I don't have the rubric for this in front of me. I'm giving you broad strokes here on how to write this report. You really need to read your lab manual, How to Write a Lab Report. It's towards the end of the manual. And you need to read the rubric thoroughly while writing this report. Okay, what was the model organism? So it wasn't a real snake. You have to tell me that, just briefly. Just what it was, why it was a good model. Why is clay a good model? You tell me. Okay, next. Research hypothesis, if and then. I don't need your statistical hypothesis, I need your research hypothesis. So remember, if is your actual hypothesis, meaning your tentative explanation of why the variables are related. And is what you're going to do, and then is what you expect will happen if your prediction of how the variables are related is correct. So if exercise requires oxygen and releases carbon dioxide, and I run for 20 minutes, then my respiration rate will increase. I will have to breathe more frequently. Okay, there's an example. Okay, but make sure it's thorough, accurate, and well crafted. Now, here's the really important thing for the intro and the whole paper. Make sure that everything flows. It's a complete thesis. No weird sentences that are just definitions of words crammed in randomly, like the independent variable was this, the dependent variable was this. That's not writing. That's just like bullet points. What I need is a well-crafted introduction. Imagine that if that introduction could fall on the ground and the sentences fell off the page, you would be able to put it back together again in the right order, because it wouldn't make sense any other way, because it had such a good flow to it that one sentence led to the next. That's what you're shooting for when it comes to writing. Proofread, edit, change. Have your someone at your house read it and make comments. Okay, results. You're going to skip materials and methods, at least for my section, because I provided it for you. So you don't have to add that one in. Results. You need written results. Many of you have done this already for an assignment. Quantify the trends. What percent difference were the two results? How much more did one gain heat than the other, right? Reference your figures. Do it properly with parentheses, figure 1. I don't want to see as shown in figure 1. That's not how you do it. Give a p-value. If that p-value does not have an exponent on it, give the actual p-value. So if it's like a really tiny number with an exponent, you can say it was less than 0.05. Well, let me backtrack on that. In the written results, you should just give the p-value no matter what. In the caption, if it's really tiny, you can put it was less than 0.05. But if it's not super tiny, give the first three numbers after the decimal point or so. All right, use your own wisdom on that. But give the p-value. Okay, so quantify the trends, reference the figures. In the figure itself should be beneath the written section, and then underneath that, of course, is the caption. Make sure you do the error bars correctly. Make sure you put everything that needs to go in that caption. There's an example figure at the end of the lab manual. All right. How do you know what kind of graph to make? You should probably know this by now. You've made enough graphs on how to determine this, and a lot of you probably know, at least by gut feeling, which is the right kind. But how do you know? Well, we've been doing scatter plots, or basically kind of like a line graph, a lot in Bio 1 and a little bit in Bio 2. When do you use that kind of graph? That's when you have continuous data on both axes, meaning numbers on both axes that are continuous, like ethanol concentration and beta cyanin leakage. Okay? Discrete data is data that's like category, male, female, perpendicular versus parallel. When you have data like that, then you have to use a column graph. Scatter plots do not make sense anymore. And so students sometimes forget how many, every graph we've ever made, we average data together. Don't forget that now that you're making a graph over this data. You average your data and you have columns, right? It's pretty simple. Okay, now we're into the most important part, this and the introduction being the most important parts of the paper. Probably the longest part of the paper is this one, the discussion. Sometimes we call it the conclusion. Okay, in the introduction you start broad, background that's not specific to your experiment, but just background on like homeostasis, thermoregulation, surface area to volume, however you want to tell your story, and then you get more and more narrow, and by the end of the hypothesis, or by the end of the introduction, you're talking about your experiment, right? The discussion's the opposite way. You start talking about your experiment, and then you get broader and broader, and then apply what you figured out in your experiment back to the greater world of biology. So, was your hypothesis supported? Tell me that right away. Yes or no? It can't be kind of supported. It's yes or no. And explain by referencing the data. Okay? And you can cite your figure again there, right? Then you're going to relate what you found back to your background to explain what happened and why. Why did this one gain heat at a different rate than this one? Then why is that important? Relate it back to what animals actually do and cite the papers where you found that information. Citations are absolutely necessary here. Remember, I am requiring two primary literature sources, not websites, primary papers that you cite, and the textbook. There are videos on how to find primary sources on my Blackboard page, and I can make one available for other instructors as required, but you can find them just on the one search on the Torreson Library Blackboard page. So citations are a must, and you're going to then have a conclusion that's based on your results, a logical conclusion that is based on what actually happened. And once again, remember to read the How to Write a Lab Report guide and the rubric, because there may be little things I'm not mentioning here that you can do, that you need to do. Okay? And you need to have your future work laid out. And I don't want something lame like I would do it again with different colors of clay. Oh, okay. Why? Why is that important? Why is that biologically relevant? Anything you tell me, you got to tell me why, and it has to be compelling. All right. Then last You're going to have a literature cited section. You have to have 3 references here. 2 papers in your book. 2 primary sources, right? And make sure you follow proper APA citation format. If you have no idea what that means, Google it. Google is your friend. Okay? Google it. Look it up. What does that mean? How does that work? Look it up. Proper format, very important. Okay, so that is the paper in a nutshell. You have some time to work on it. I look forward to reading the best that you could put out there, because I expect this paper to be really good, and it needs to be really good. So good luck. And one thing you can do, a couple other points I want to make from my classes. I might encourage you to use the message board on Blackboard to peer review each other's papers. I'll let you do that on a volunteer basis if you want to, and pair up on there and do that. But here's something really important. I usually don't recommend this, because when you let someone borrow your paper, sometimes people copy it. So remember, there's a strict zero tolerance cheating policy on here. If you plagiarize off the web, if you plagiarize off a fellow student, you'll get a 0 on this paper. Okay, and you don't want that. So do not plagiarize. And also, just one more thing when it comes to lit cited, be sure that all of your references are cited in your paper and in the lit cited section, and never quote directly from a paper. You only paraphrase and incorporate the ideas from that paper into your own paper, and give credit to the ideas. Never, ever quote exact words. Okay? All right. Good job, everyone. This is something that you've got this. You've been practicing this. It's not a big deal. I just wanted to give you a video on what I expect, and let you get working on that as soon as possible. And have a good spring break, and I will see you all on the internet after break.